This is section 1.1 for pre-calculus. This is everything you've learned back in your Algebra 1 days related to linear equations. Okay, so we're just going to kind of fly through the basics here. So remember slope. Usually when I say, what do you remember about slope? Everybody wants to say y equals mx plus b. But y equals mx plus b is not just slope. It's slope and y-intercept, right? The m is the slope. So let's just think about the m part of the slope. If you're looking at a graph, right, you're thinking kind of up and over, and textbooks would write that as rise over run. And what that means is, what's the change in y values over the change in x values? Remember that little delta, that triangle delta means change in. But probably the more practical, the way students are actually going to use it would be you would say y2 minus y1. So you're subtracting your y coordinates on top, subtracting your x coordinates on the bottom. Hopefully that makes sense, because if it's the rise, it's the y values that are changing, and if it's the run, it's the x values that are changing. Okay. Parallel lines, I'm sure you remember this, have slopes that are equal, whereas perpendicular lines have slopes that are the opposite, or you might say negative reciprocal. Okay. And we're not going to do too many examples of all this kind of stuff, because this is really going to be kind of like the third time you've gone through it. So we're just doing a quick run through on this. Okay. Horizontal lines, there's a couple things you need to remember about horizontal lines. Not only do they have a slope of 0, but you also need to remember that the equation of a horizontal line, remember, is going to be like y equals some number. It might be y equals 2, y equals 3, y equals 5, whatever. And then this is going to really insult your intelligence, but remember, horizontal lines go this direction, right? Okay. So what do we know about vertical lines? Well, vertical lines have a slope that's undefined. We know that the equation, I'm sure even if you forgot now you can guess, the equation, not y equals now, but x equals some number. And then remember, the direction that a vertical line goes is something like this. Okay. What do we know about the x and y intercepts? Well, yes, it's where the graph touches the x-axis or the y-axis, but specifically, if it's the x-intercept, then you know that the y-coordinate is 0, so it's some x number comma 0, whereas if it's the y-intercept, then you know it's the x-coordinate that's 0, and then you have some y-coordinate. Okay, we already mentioned the slope-intercept form of the line. Remember, the slope is the m, the intercept is the b. So this is the one that's the mx plus b. And that's probably the one that you probably are most familiar with from Algebra 1, Algebra 2, because that's what algebra teachers do. They emphasize this mx plus b. They'll mention point slope. So you have some point, I'll call it x1, y1. And then, of course, the slope is still the m, but the equation for point slope is going to be y minus y1 equals m, and then x minus x1. And again, I'm sure you kind of remember this and you've used it. You probably haven't used it as much, but going forward in pre-calculus and calculus, this is going to be the one that we're probably going to use the most, probably even more so than mx plus b. And the value of these is mx plus b. Yeah, this is great if you're trying to graph a line, but the point slope is much better if you're trying to write an equation of a line. Write equation of a line. Okay, so let's do some of the basics. I want to find the slope, right? So I'm going to subtract the y's on top, x's on bottom. And by the way, you're in honors pre-calc now. You don't need to be writing out every single step. I mean, if it makes you feel better, great, do it. But if you can just do the basic computation in your head, more power to you. Okay, so on top, 8 minus 4. On the bottom, 6 minus negative 3. My slope is 4/9. Okay, number 2, my slope is on top, 5 minus 5. On bottom, negative 6 minus 3. And you all realize it doesn't matter if you do the second point minus the first point, or if you do the first point minus the second point, as long as you do the y's in the same order you do the x's. Okay, so in this case, if you have 0 over negative 9, doesn't that actually equal 0? Which basically tells me this is going to be a horizontal line. But they only asked for the slope, and the slope is 0. And so look at number 3. This time on top, so I'm just going to say 8 minus 4 is 4. On bottom, negative 2 minus negative 2 is 0. And what does that equal? It's not 0, but remember, if the 0 is on the bottom, it's undefined. Okay, so number 4 here, well, if it's a horizontal line, what's the slope? The slope is 0. What about number 5? It's a vertical line, so we know the slope is undefined. And then on number 6, I don't need to find those ordered pairs, right? I can do the idea of rise over run. So you always want to go left to right. So this is my leftmost point that I'm going to look at. And so I'm going to go up 1, 2, 3, and over 1, 2, 3, 4. So the rise is 3 and the run is 4. Okay. Number 7, so I'm graphing, which is why this mx plus b is a great form. So I put on my y-intercept of 3. My slope is negative 2, and you can mark off that negative 2 over 1 as many times as you need to. And then draw your graph. Just make sure you extend it the full length. I'm not that worried about having the arrows on the ends. We know they're there. They're implied. But just draw the graph the full length. Now, number 8, it's probably going to be easier to graph this if we change it into slope-intercept, right? So let's solve for y. Let's see. So I'm going to subtract 3x, and then I'm going to divide by 2. Okay, so usually on these, the mistake is in the solving for y as opposed to the graphing. So just be careful when you solve for y. So my y-intercept is 5. My slope is negative 3/2. So down 3 over 2. Again, mark that off as many times as you want. That'll help you draw this graph, the full extension of the grid there. Okay? So x and y intercepts. So you don't have to graph the line in order to find these. Remember how we said for an x-intercept, we know the y-coordinate is 0. Okay, well, if you plug a 0 in for y, you're just going to have x equals 4. And then the y-coordinate, for the y-intercept, we're going to plug 0 in for x. All right, if you plug 0 in for x, all you're going to have is negative 2y equals 4. So y is negative 2. Okay, over here for the x, plug in 0 for y. If I do that, it's kind of like that's not even there, right? So if 3x equals negative 15, isn't the x going to be negative 5? And similarly, for the y-intercept, if I plug in 0 for x, well, plugging in 0 for x is like that's not even there. 5y equals negative 15, so I'm going to have negative 3. Okay, so now we're into the writing equations of lines. And this is much more what we're going to see later in pre-calculus and more in calculus. Okay, what we've already done, yeah, big, huge review of Algebra 1. And this is still a review of Algebra 1 and 2. It's just that now we're into the writing equations. Okay, writing equation of a line that passes through the point and has the slope, right? This is point slope. So this is my x1, y1, and my m. So I'm going to say y minus y1 equals m, and then x minus negative 1. Now, this doesn't say we have to change it into slope-intercept. It doesn't say you have to solve for y. All it said to do was write an equation of a line. This is a perfectly acceptable form for the equation of that line. You don't have to change it unless they tell you to. Okay? Number 12, write the equation of the line shown. Now, you might be tempted to do mx plus b, but we don't know exactly what that y-intercept is. Okay? I do know that the slope is down 1 over 3. And so I can choose either point I want. Remember, I need one point and a slope. I don't need both points necessarily. So I'm just going to use that point right there. I know that point would be 2, 0. So I'm going to say y minus 0. And no, you don't have to write that. I just wanted to show you that I was doing it. Equals m. And then x minus, my x coordinate is 2. So that is an acceptable equation. That's not the only one. Maybe I had used this point instead, okay? So it might have looked different, but it would have been equivalent, okay? Number 13, equation of a line. All right, so what two things do you need? You need a point and you need a slope. I have a point, but I don't have a slope. Okay, find the slope. So the slope is 10 minus negative 2, 2 minus 5. So my slope is negative 4. And now I can choose whichever point I want. I'll just pick the first one, but it would have been fine to pick the second one. So y minus, so that y1 is negative 2, equals, we said the slope was negative 4, and then x minus 5. So again, I chose the first point. You could have just as easily have chosen the second point. It would have looked different, but it would have been equivalent. Okay? Number 14. Now, hopefully at this point you're thinking, well, why would you give me another one, 14, just like number 12? It's just, I have 2 points on a line. Well, because I want you to know when to think smarter, not harder. On number 12, I had to use point slope because I didn't know the y-intercept. But on number 14, they specifically give me the y-intercept right here of 2, don't they? So on this one, I could just use mx plus b. I can tell the slope is 3 over 1. So y equals mx, and then the b is negative 2. So I didn't need point slope. So it's a rare situation where you can use slope-intercept on these. But if you can, great, use it. Okay? Number 15, write the equation of a line that passes through the point negative 2, 3, and is parallel to this line. Well, if it's parallel, don't we want the same slope? So I'm just going to use negative 4, but I'm going to use it with this point. So y minus y1 equals m, and then x minus negative 2. Now, letter B is saying, hey, use that same point up above, but this time I want perpendicular. So instead of a slope of negative 4, we're going to use positive 1/4. Still the same point though, so y minus 3, now we're using 1/4, positive 1/4, and then x plus 2. Okay, so new question, number 16. Again, you should be kind of leery. Hey, I already did one like this where I was given 2 points, right? And I need a point and a slope, so let's start by finding the slope. So I'm going to have 8 minus negative 2. And on bottom, 3 minus 3 is 0. Oh, wait, that's undefined. Now, I can tell you right now, if you're going to make a rookie mistake, so stop writing for a second. If you're going to make a rookie mistake, you're going to say, okay, I'll do point slope. Y minus 8 equals, my slope is undefined, x minus 3. No, we don't want that. You never want to write an equation that has an undefined in it. That's bad. Bad. Don't do that. So what am I supposed to do? Well, if it's an undefined slope, doesn't that mean it's a vertical line? And if it's a vertical line, doesn't that mean the equation is going to be x equals some number? Well, look at both of those points. Doesn't matter which point you pick, doesn't x always equal 3? So the equation of that line is x equals 3. Number 17, find the slope. We're going to get 0 on top. And then on the bottom, we're going to get 2, which is 0. But again, this is kind of like a special case, right? Because if the slope is 0, can't I just think of this as being a horizontal line? And if it's a horizontal line, wouldn't the equation just be y equals something? Well, look at both points. No matter which one you pick, isn't y equal negative 2? Okay, number 18. Write the equation of a line that has an x-intercept. Well, really, if they're giving you an x-intercept, they're giving you an ordered pair, right? And then it also goes through the point 2, 3. Well, hey, if you know 2 points, then you can find the slope, right? So 3 over negative 3, negative 1. So now pick either point. I don't care. So I'm going to say y minus 0 equals, whoops, I wrote equals again, equals my slope, and then x minus 5. So that was because I chose the 5, 0 point. Could have chosen the other one, doesn't matter. Number 19, equation of a line that passes through this point and is parallel to the x-axis. I only have 1 point, and they don't give me another one so I can find the slope. So let's think about this. Here's my xy axis. I have a point 4, 5, so let's say the point 4, 5 is over here somewhere. I want to draw a line that goes through that point, and I want it to be parallel to the x-axis. So it's going to be a horizontal line. Okay. If it's a horizontal line, wouldn't the equation be y equals? Well, what does y equal? Y equals 5. Okay, so that is section 1.1.